Welcome back, friends, to your own channel. Today, we are going to learn about how to conduct ANOVA in Excel. And I'm going to show you two different methods through which you can conduct one-way ANOVA in Excel. First method will be conducting ANOVA by Data Solver menu. And this will be an automatic method to perform. Now, the second method is manually calculating ANOVA and constructing entire ANOVA table. Before we start, if you're liking the content which I post, I would suggest you to hit the like button. And if you're new to the channel, please subscribe my channel and keep the notification icon on. Let's begin. We'll see the first method of conducting ANOVA in Excel through data analysis option. And for that, we need to enable certain options in Excel if you don't have it already. Let's go and click to the file menu. Once you go to the file menu, you'll find options. Click on the options. As you click on the options, you navigate yourself to the add-ins here. Click on the add-ins. As you click on add-ins, you'll find the option manage Excel add-ins. You click on the go there. Once you click it, you find this dialog box open. Select the analysis toolpath and hit OK. As you do that, you will find in your data menu, the data analysis option is available now. With this help of data analysis option, we'll perform the one-way ANOVA. Now, if you are new to ANOVA or if you're not knowing anything about ANOVA, I would highly recommend to watch my ANOVA explainer video. It will give you a logical structure of what ANOVA is all about. So in today's exercise, we are going to do practical ANOVA implementation in Excel. Let's begin. Here we have a data of three different car make. We have a General Motors, we have a Ford, and we have a BMW. We have collected data of 10 cars in each of these three make about their emissions. And our objective is to compare whether the emissions in each of the three groups, the mean emissions particularly in each of these three groups, are same or equal, or is there any difference, or are they not equal? Now, it's worth to note that we have 10 samples in each of the group. We'll click on the data analysis option here. Once we do that, we go to ANOVA single factor here. As we hit OK, we've been asked to provide input range of the data. I'll go to the input range, I'll click there, and I'll select my data here, which will be my input data for the ANOVA test. I select this data and hit enter. Now, your data can be grouped by columns or it can be stacked up in a row. However, I have grouped my data in column. So I have three different groups adjacent to each other. So I selected columns here. In case if your data is stacked on top of each other, you can select rows. Now, since I selected columns, my labels are there in the first row. What do I mean by label? Is basically this General Motors, Ford, and BMW. That's my label for the data. So I'll select labels in the first row option. Now, next is alpha. And alpha is nothing but level of significance. If you don't know what is level of significance, I shall make a separate video for you. But for now, assume alpha to be a kind of a threshold value, basis which you will either reject your null hypothesis or you will keep the null hypothesis. Now, if a p-value obtained through ANOVA test is higher than alpha, we will keep the null hypothesis. However, if your p-value is less than alpha, we will reject the null hypothesis. Let's keep it 0.05, that is 5% in our case for now. The output option for ANOVA results, there are three options available with us. One is the output range, wherein you can define where do you want your output to be displayed in the existing sheet and you provide the output range there. The second option is you can store your results into new worksheet within the same Excel workbook. And the third option is you can open a new workbook and store your results there. For now, I am keeping my results into the new worksheet option and I am giving the name as result worksheet. And I'll hit OK button. As I do that, I'll immediately get the results of ANOVA. Now, if you see, we have two tables here. The first table is nothing but a summary table of the data, which shows you what your data is all about on which we have performed the test. So we have three different groups: General Motors, Ford, and BMW. For each of these three groups, we have 10 different records available with us. Now, sum is nothing but absolute sum of value in each of the group. So for General Motors, it's 2100, Ford 2200, and BMW 2300. And average is nothing but the mean of records in each of the group. So General Motors, we have 210, 220, 230, and so on. Okay, variance is nothing but how each of your point is far away from your mean. And if you don't know what is variance, or if you want to know variance in detail, please watch my video on variance, and that will give you good exposure about what is variance. Let's see the next table. In the next table, we have ANOVA table, which is our ANOVA test result table. And this is a table we are interested in. So as you know that the sources of variation can arise in ANOVA because of two reasons. One is between sum of squares and second within sum of squares. So you have two groups here, between groups, which is nothing but between sum of squares, and then you have a within groups, which is nothing but within sum of squares. Now, the first column which you see here, SS, which is nothing but sum of squares. Now, sum of squares is nothing but how each of your point in that particular group is away from that group's mean. And if you take that difference, that is your difference between that point and the mean of that group. And if you squared up that value, that is your sum of squares. So you have between group sum of squares of 2000 and within group sum of squares of 390. And total sum of squares is nothing but 2390. Next is degree of freedom. So degree of freedom in statistic means that number of values, the calculation of a statistic that are free to vary. Now this sounds complicated, right? But simplify this term for you in this case. Degree of freedom is for between groups. We have three different groups for which we have measured sum of squares. Now degree of freedom for between the groups is number of groups minus 1, that is 2. For within groups, degree of freedom is nothing but total number of observations minus the degree of freedom already occupied by between groups minus 1. And our overall degree of freedom is nothing but 27 plus 2, which is 29. MS is nothing but mean sum of squared. Now mean sum of squared is measures sum of squares at equality. Now as you see that degree of freedom varies for between group and within group. So we need to check sum of square at equality, and for that we use this term called mean sum of squared, which is displayed as MS on your screen. How do you calculate mean sum of square? Is when you divide your sum of square with degree of freedom, it will give you mean sum of square. So in between group, we have sum of square 2000 and degree of freedom is 2. So mean sum of squared value is 1000. In case of within groups, it's 390 divided by 27, which will give you value of 14.44. Now, next is to calculate F statistic. ANOVA follows F distribution, and for that we will calculate F statistic. And F statistics is nothing but it's a ratio of between sum of square divided by within sum of squares. In our case, it's 1000 divided by 14.44. That gives you value of 69.23. Now, let's pause for a second and think what this F value signifies. As you can see, F value suggests that your between group sum of squares is 69 times than your within group sum of square. What it means that the three different population which we have with us, their means are separated away and the variance between their means are 69 times more than the variance which you have within each of the group put together. And that's your F statistics. Now seeing this F statistics 69, we feel that this group means there are high probability that they are not similar. But let's check this probability value of the F statistic. So we calculate the p-value for getting this F statistics in F distribution. ANOVA table already has this value. So the p-value for us is 2.35 into 10 raised to minus 11, which is very small, and p-value is smaller than alpha value. Remember, our alpha value we have taken is 0.05. So here 2.35 into 10 raised to minus 11, which is definitely smaller than 0.05. And since it's smaller than 0.05, we reject our null hypothesis and we say that the mean emissions from cars of General Motors, Ford and BMW are not the same. They are different. Next we have F critical value, and F critical value is nothing but the critical F statistic value beyond which we will reject our null hypothesis. So that in our case it's 3.35, while our F value is way above this value, which is 69 in our case. Let's go to our second method of calculating ANOVA, and this is more interesting. In this method, we are going to calculate sum of squares and entire ANOVA table manually in Excel. We have the same data which we seen in our section 1. As a first step, we will calculate the total sum of squares in this data, and for that I'll take you to the sheet total sum of squares here. So we have total 30 data points available here in 3 groups. Now we want to calculate total sum of squares. How do we calculate total sum of squares? First we need to calculate overall mean or overall average of all these 30 data points. So how do we do that? We can do multiple ways. One, we can sum up all this data point and divided it by 30 because there are 30 observations. That will give us the mean or the average value. However, we can also use average function in Excel and we provide this 30 points. As we hit enter, we'll get the overall mean, which is nothing but 220. Now, we need to calculate difference of each of the data point from the mean, which is 220. So in the first case, the data is 209. So difference from the mean 220, which is nothing but 209 minus 220, which will minus 11. Next data point is 208, and the difference from the mean is nothing but 208 minus 220, that will become minus 12, and so on. So we have calculated difference for each of the data point from mean for all the 30 data points. Next, we want to have squared difference. Since this is the absolute value, we are squaring this value. So minus 11 will become 121 and minus 12 will become 144. Minus 11 again will become 121 and so on. So we have calculated square differences for all the 30 data points. And we are interested to calculate total sum of squares. So when we add all these square differences, all these 30 square differences, we'll get this value 2390, which is nothing but our total sum of squares. Now, as a second step, we need to calculate within sum of squares, and for that I will take you to the sheet within sum of squares here. Here we want to calculate sum of squares for each of the groups separately. Hence, I have separated this 3 group and their data points for GM, Ford and BMW respectively. Now, First, we calculate mean for each of the group. So mean for General Motors observation is nothing but summation of all these 10 data points divided by 10. Alternatively, we can use average method in Excel and provide this 10 data points. And when you hit enter, you'll get the average emissions data for General Motors, which is 210. Similarly, we have calculated average emissions data for Ford, which is 220. And similarly, we have calculated average emissions for BMW, which is 230. Now, next step, we want to calculate difference of each data point from this mean. So, in the first case, the data is 209, while the mean is 210. So, our difference from the mean is nothing but 209 minus 210, that is minus 1. Next, we have 208. So the difference from the mean is nothing but 208 minus 210, that will become minus 2, and so on for all 10 data points. Now, we are more interested to have this squared value of these differences. So we have squared up these values in this column. So minus 1 has become 1 here, minus 2 has become 4, minus 1 has become 1. So these are all the squared differences which we have for all 10 data points of General Motors. If you sum up all the squared differences of General Motors, the value comes as 20. And that 20 value is nothing but that is within sum of squares for General Motors. We did similar process for Ford and we did similar process for BMW. Within sum of squares for Ford is 228 and within sum of squares for BMW, which is 142. However, we want to calculate within sum of squares for all three population together. Hence, we sum up this value. So, total within sum of squares is nothing but within sum of squares of General Motors plus within sum of squares of Ford plus within sum of squares of BMW. That is 20 plus 228 plus 142, and that will give us 390. So our total within sum of squares is 390. As a third step, we need to calculate between sum of squares. For that, I'll take you to the sheet between sum of squares here. Remember, between sum of squares is nothing but how each of your individual groups mean is far from the global mean. What is the variation between groups mean? That is your between sum of squares. And for that, we take three different makes. So we have GM, Ford and BMW, and we take mean of each make. So for General Motors, mean is 210 as we calculated earlier. For Ford, the mean for Ford is 220 and for BMW it's 230. And our overall mean for all 30 data points is 220, which is our global mean. Now, we calculate difference for each of the mean from the global mean. So for GM, it's 210 minus 220. That will become minus 10. For Ford, it is 220, which is exactly at the mean. So difference with the mean is 0. In case of BMW, it's 230. So difference from the mean is nothing but 230 minus 220, and that will give you plus 10 value. Now, next we will square up all these differences, and hence minus 10 will become 100. 0 will become 0 and so on. And we add up all the squared differences. That gives us the value of 200. Now, recall we are comparing mean here. And hence, since there are 10 samples in each of the group, we need to multiply the squared difference with value 10. And hence, that will give us value of 200 into 10 is equal to 2000. So 2000 is nothing but it's a total between sum of squares. Now we have calculated total sum of squares. We have also calculated within sum of squares, and we have also calculated between sum of squares. So as a fourth and final step, let's construct the ANOVA table. And for that, I'll take you to the sheet construct ANOVA table. As we go there, we know that sources of variation can arise because of between sum of squares and within sum of squares. And when we total it up, we'll get the total sum of squares. Now sum of squares we have calculated. Our between group sum of squares was 2000 that we calculated. And our within group sum of squares that we calculated is 390. When you sum it up, you get the total sum of squares, which is 2390. Again, this value we have calculated manually. Now, next, degree of freedom. As we know that we have total 3 number of groups, and hence our degree of freedom will become 3 minus 1, 2. For within group, we have total 30 observations, and our degree of freedom is nothing but total number of observations, which is 30, minus the degree of freedom already occupied by between groups, that's 2 minus 1. So our total degree of freedom in within groups case will become 30 minus 2 minus 1, that is 27. And our total degree of freedom is 29. Let's calculate the mean sum of squared value. And how do you calculate mean sum of squared value? Which is nothing but sum of squared divided by degree of freedom. For between groups, it's 2000 divided by 2, that becomes 1000. And for within group, 390 divided by 27, that will become 14.44. Let's calculate our F statistic, which we seen in our section 1. So F statistic is nothing but ratio of mean sum of squared of between groups divided by within groups. In our case, it's 1000 divided by 14.44. That gives us the value of 69.23. And let's calculate the probability value of getting this F statistic. And how do we calculate p-value? Since ANOVA uses F distribution, there is a formula in Excel, f.dist.rt. Now, f.dist is nothing but it's a F distribution table, and .rt is nothing but it's a right-tailed hypothesis. So we took as .rt. And once we do f.dist.rt, we need to provide the value of F statistic, and we need to provide both degrees of freedom. Once we do that and hit enter, our p-value we are getting is 2.34 into 10 raised to minus 11. Now, I would like to draw your attention. The ANOVA table which you see here is exactly the same which you have seen in our automatic method. So, this table. And this is how you can manually calculate or construct ANOVA table in Excel, and you know each of the calculation which ANOVA takes care of. Please like, share and subscribe my channel. Thanks for watching. Bye-bye.